Alright, in this video we're going to be talking about phone numbers and license plates. But before we do, let me kind of give some context to where we're going with this. Alright, and so just by looking at the examples here, the Georgia license plates over the years, if you notice in the 1950s you had a whole bunch of numbers and this A, and I just pulled all this off the internet, so I'm not, if I had other examples I'd be able to make a little more comparison, but let's just say, for example, in the 1950s, the Georgia license plate started with a letter and then a whole bunch of numbers. But then once you got into the 70s, they started to incorporate more letters into the license plates. And then if you skip over to the 2000s, notice what we have here. We have 4 numbers and then 3 letters. So basically, if you're going to make your conclusion, and I'm going to type this, and that is this, and that is the more letters, numbers, means more, or not even possible, more license plates. Alright, now you might be asking, well, who cares? Well, the problem is the state, the population, the Georgia population, and again, bring in context, has increased over the years. Now, I'm totally making this up, so please don't think that I researched this, but let's say in 1950, the population of Georgia was 1 million. All right, now in 2020, again, totally making this up, so don't be like, I don't believe it, because it's not true. I don't know. But I think in 2020, we now have 14 million people in the population. So the thing is, when you have more people, you have to have more, let's just say more license plates in the context of this question. So moving on, again, a little more context. Now, again, I pulled this off the internet, but I'm going to use this as the example. When I was growing up, I'm 40 years old, but when I was growing up, phone numbers, all I had to do was type in the 7 digits. All right, so like, for example, if my phone number had an area code of 404, 555, 2, all right, there it is. And if I was to make a phone call, if I was going to make a phone call, all I had to do was dial those 7 digits. All right, it wasn't until I'll probably say my junior year, so that would put me at 1997, that we actually had to put in the area code. Okay, and the reason for that goes back to what we talked about just now, and that is the Georgia population, and that is, as more people are moving in, you're going to need more phone numbers, you're going to need more things for each family, each person to have, which in this lesson, it's going to be phone numbers and license plates. All right? All right, so context is over. Let's go ahead and dive into a couple of questions. All right? So it says, determine the total number of possible outcomes in the situation. All right, so here is basically what we're going to be doing. All right, so I guess this would be question number 1. How many possible phone numbers can you have without an area code? Now, we do, in these type of problems, we do have some restrictions. So the restrictions go along with our blueprint here. It said ABC. All right, so a phone number has 7 digits. Now, you might be saying, well, a phone number is 10 digits. Well, you're right. You would have to type in 10 digits, but the first 3 is the area code. So what I like to do is I like to create blanks. So first number, second number, third number, there's my little dash, like in a phone number, blah, 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 writing with my mouse, so it might be a little weird. It says A must be a number greater than 3. Notice that A is the first number of our phone number here. So it must be a number greater than 3. So that means it would have to be anywhere from a 4 to a 9. All right, now you might be asking, well, why not 10? Well, 10 is a double digit, and we're only looking for single digits. So 4 to 9, let's see, 4, 5, 6, 7, 8, 9. Those are 6 possibilities. So there's 6 possibilities that could go in this very first blank here. Now, B must be a number greater than 2. So if it must be greater than 2, then that means it could be a 3, it could be a 4, it could be 5, 6, 7, 8, 9. So it's any number between 3 and 9, which I believe that is going to be 7 possibilities. 3, 4, 5, 6, 7, 8, 9. That's right. Now, C cannot be a 0. All right, now C is the third number. It cannot be a 0, so that means it can be a 1 all the way to a 9. All right, so when you do the math, you get a total of 9 possibilities. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that's 9. Now, the last 4 here, the last 4, this guy, this guy, this guy, and this guy, there's no restrictions. So if you have no restrictions, all right, I'm going to type this just so you can make this out. So if you have no restrictions, that means it can be a 0, it could be a 1, it could be a 2, it could be a 3, it could be a 4, 5, 6, 7, 8, 9, which gives you a total of 10 possibilities. Oh, I did not spell that right. I put too many L's in there, I'm sure. But there it is. All right, so it could be 10 possibilities. So that means in the last blanks, 10 possibilities can go there. 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 All right. Now it says how many phone numbers could be used. Well, you have 6 possibilities, so I'm going to take 6 times 7 times 9 times 10. 10. The dot represents multiplication. So since not having the key in front of me, I got to do this one. All right. So that means I got 3,780,000 possibilities. I'm crazy with my typing there. All right, so I have 3,780,000 possibilities. All right, now this is a continuation, and this question kind of throws people off. All right, it says if the area code was 878 and 714, how many possibilities could be used? Now, these numbers are not familiar, so I'm going to use an example of things that are familiar. All right, so let me insert one page here. All right, so let's go with today's current phone numbers. All right, so let's say John's phone number was, so John had a phone number of 770-555-1200. That's John's phone number. Well, Al's phone number, let's say, is 678-555-1200. Let's say Bob's phone number is 404-555-1200. Notice that the phone numbers are exactly the same except the area code. All right, and then Charlie, his phone number is, oh goodness, I'm missing one. I think 670, is that the area code? I don't know. All right, 555-1200. All right, so basically what you have is the phone number of, now please don't miss this, the phone number of 555-1200, okay, it is being used 4 different times. It's being used 4 different times, okay? Now, with an area code, a phone number could be used more times. So, for example, again, make this connection, and that is, if you have 2 area codes, okay, that means the phone numbers, the possible phone numbers get doubled. So you have double possibilities. All right, if you have 3 area codes, I'm sure you can pretty much figure out what I'm about to put here, and that is you have the triple the amount of possibilities. Because again, looking at this example with John, Al, Bob, and Charlie, the same phone numbers are being used again and again and again. The only difference is the area code makes it different. All right, so using that and continuing our question here, and that is, if you have 2 area codes, all right, in this situation, you have 2 area codes, that means that all the possibilities, which is 3,780,000, 1, 2, 3, 4, will get doubled. You have a grand total of 2 more, so that ends up being 7,568,000. All right, possibilities. Yeah. All right, pretty simple. Now, the state of Montana has license plates. All right, so same concept, except you're just dealing with license plates. So it says, in the state of Montana, the DMV issues license plates under the following restrictions. The first letter cannot be a T, a G, an X, an O, or an I. All right, so when I start building this, I like to put blanks. All right, so it says the first letter. So I'm going to indicate the first letter by putting one blank here, the first letter. Now, letters, again, giving you context to the situation off to the side here. All right, letters A through Z gives you 26 possibilities. All right, 26 possibles. But you cannot use a T, you cannot use a G, you cannot use an X, you cannot use an O. So there's 5 possibilities that you can't use. So that means in this first letter, in this first blank, you have a total of 21 possibilities that could go there. Okay, now keep reading. Restriction 2. The next 2 letters cannot be a 0. All right, so the next two numbers. So blank, blank. They cannot be numbers, so that means they would have to be 1 through 9, 1 through 9. 9 possibilities, 9 possibilities. All right, the third restriction. The next 3 letters cannot be an X. So the next 3 letters, 1, 2, 3, running out of room here. It cannot be an X. Well, remember, letters have 26 possibilities, and if it can't be an X, that means it's going to be 25. So 25 possibilities, and 25. And then lastly, the last character must be a digit, and it cannot be a 0. So that is another 1 through 9 situation, which you have 9 possibilities. Remember, 1, 2, 3, 4, 5, 6, 7, 9. So how many license plates are possible? Well, just like phone numbers, you multiply. 29 times 9 times 9 times 25 times 25 times 25 times 9. Ooh, big number. I'm going to type it, and then we're going to put some parentheses, or not, commas in there to see where we're at. I think we're in the billions here. 139, 20125. All right. Comma. Oh, we're still in the millions. All right. So 239,203,125 possibilities. That means you can make all those different license plates with that combination. So everybody would have a different one. All right, so it says, suppose a new system allowed for a new letter to be added to the end, but it could only be letters A through H. All right, so I've kind of ran out of space here. Let's see if I can move stuff. And I could. All right, so it says, suppose a new system allowed for a new letter. All right, so I'm just going to use a different color here. A through H. All right, so a new letter, A through H. So A through H, I'm just going to draw a line, just keep me from having to draw more. A, B, C, D, E, F, G, H. I got 8. Hopefully you did too. 8. All right, so that number's going to get a lot bigger. So when I multiply all that with that 8 included, oh goodness, that's a lot. All right, so that means 2, 5, 1, 2, 3. All right, so let's put some commas in here. I got to be in the billions now. I am. 1 billion. Well, you can read it. That's how many possible license plates there are. All right, so I'm looking at the time. We're getting a little long here. Let's see what we can. Oh, we just did that. All right. All right. So questions that you might be saying. All right. So Arizona uses 3 letters followed by 3 digits. All right. So what I recommend with these type of questions is that kind of draw it out. So 3 digits. So 1, 2, 3, and then 3. I'm sorry, 3 letters, and then digit, digit, digit. Draw it out so you know. I like using blanks because when I use blanks, I know something's got to go into the blank. So it says, how many license plates can be made using all letters in the alphabet and numbers 0 through 9? Well, these are all letters, so letters is A through Z, so that's 26. I'll spare you to sing in the alphabet song. And then the digits, or the numbers, I'm just putting D for digits, 0 through 9, well, that's a total of 10 possibilities. Now, at this point in time, you should know what you're doing. You multiply all these together. All right? So the questions that you're going to run into are very similar to the ones we just did. A little different here and there, but it's not going to be too challenging, I don't think. As always, if you have any questions, please let me know. Thank you for watching.